Good morning, everybody. My name is Britta Schmigotsky. I am the project manager guiding this project together with Adam Senian, who just had the opening words. Now I'm sharing my screen with you. Here we are. I hope everything is fine. Yes, I'm very, very happy that I can introduce our project to you. We, that is Adam Senian, the lead partner, as I said before, and me, Britta Schmigotsky, I'm from Athenecom. We would like to go on a journey within this project phase, looking at the past, talking about the present, and then also have an outlook to the future. So let's start. How did we start? How did this project start? Already, Mr. Karstan, thank you very much for this inspiring opening speech. You already mentioned a lot of issues that are relevant and that also have been relevant for us. So why did we start? Of course, the partnership, we wanted to contribute to the European climate goals. At that time, at that time means around 2015, 2016. The development of the project started. So it was the renewable energy targets for 2030. We also had in mind the existing EU directive on energy efficiency and energy performance in the building stock. So how can sustainable heating contribute to fulfill the goals or the directives and regulations in Europe here? Very important have been the energy performance requirements for building and for construction. So also here we want to consider what can district heating do. Everyone speaking about sustainable smart cities and urban quarters, but already then we thought, hey, one aspect may be missing. It's where are the smart grids? They have not been mentioned as much as other aspects of smart and sustainable cities. So this is why we had a look at the low carbon heating and cooling sector. And at that time, already, for example, Heat Roadmap Europe and other important documents, as well as European approaches, came on. So we thought this is a topic which is relevant for us. Another motivation, I already mentioned it, has been the relevance of district heating for energy efficient cities. A lot of our partners come from the planning sector and like, for example, Seebau. And what we do when speaking about energy efficient cities, energy efficient buildings, we look at the building. We look at how to renovate energy efficiently, renovate this building. And of course, we also look at the urban context. But what we wanted to do is to look at pipes. We really wanted to focus in this project on the relevance that sustainable heating supply has for buildings and for cities. Who supported this idea of doing so? Our supporters, that is the Interreg Baltic Sea Region program. A lot of you are in the European or cooperation sector active. So you may know Interreg, Baltic Sea Region. This is the geographic focus. You see here the program area. And why are they supporting projects like LowTEMP? Because they would like the Baltic Sea region more innovative, more accessible, and more sustainable. They do this in 4 thematic priorities: innovation, transport, and EU strategy. And our priority is the priority natural resources. And within this priority, we have the objective energy efficiency. So the project is located within this objective. again, the key facts of the project. Aim making district heating more sustainable in the Baltic Sea region. We are 19 partners from 8 EU member states and from Russia, so Estonia, Latvia, Lithuania, Poland, Germany, Denmark, Sweden, and Finland, and Russia. The lead partner, you already met him, Adam Senian, Poland, the IMPAN. Project duration, 3 years, basically, but as you can see here, October 2017 till December 2020, we had a 3 months prolongation due to COVID reasons. And the budget, 3.8 million euros. I would like to introduce the whole team. Our partnership, 19 partners, I already mentioned it on the slide before, from 9 countries. And we also have 19 associated partners. These are partners that support our activities. Where do these partners come from? You can read the names here on the map, but they basically are municipal, regional, and national authorities. And we have district heating suppliers in our partnership, planners, engineers, energy agencies, research institutions, district heating associations, and business development agencies. The team is not only these 2 you now hear, but the team is quite a bunch of people. This is the LowTEMP partnership. I'm happy to introduce them, and you will hear them in the afternoon. As you can see here on the photos, quite often we wear helmets because we were on study visits, visiting places where we see innovative, but also not so innovative district heating supply structures in the Baltic Sea region. Of course, we also met for seminars, and as you can take from the picture here in the corner, due to COVID-19 reasons, we started to meet in, I don't know, spring 2020. We started to meet virtually, like today. Coming to the topic, again, I would like to mention the background and the challenges for this project. Of course, in all countries, you know this, in the Baltic Sea region countries, there is a long tradition and a high share of district heating. The existing systems have similar characteristics. So it's good background to start with jointly. Also a background, but not so good, is that there is a bad technical conditions of the devices in district heating infrastructure, and there are heat losses from the grid. Also, still high share of fossil fuel used as primary energy source, and at the same time, a low renewable energy share in district heating. These facts, these systems meet the efforts to increase the energy efficiency in the building stock, which means it's clear, I mentioned it in the beginning, if the buildings are energy efficiently refurbished, we need to adapt the energy supply systems. What also has been a challenge for us in the beginning were the different economic and legal framework conditions in the countries. So we thought we need to have a look at this. Further challenge, lack of instruments to tackle existing barriers in low temperature district heating, lack of municipal and regional strategies on the integration of such systems, and also very important challenge or problem, financial barriers for the implementation. So based on these challenges, what did we aim to do? We wanted to do the following. We wanted to collect and provide information and data on low temperature district heating and district heating in general. We wanted to assess environmental and economic benefits of the systems. We wanted to develop guidelines and strategic approaches on how to plan, finance, install, and manage low temperature district heating systems. We wanted to realize pilot measures. We wanted to do something tangible that fits to the local and regional conditions in the partner countries. And we wanted to increase knowledge, very important, on smart district heating systems and the installation of such systems. And these efforts are supposed to pave the way to fourth generation district heating, which you see here in this graph. Now, left slide from my side. How did we do this, or how did we want to achieve these aims? We developed a district heating knowledge platform to collect information and data. We developed various sustainability assessments to assess the benefits, economic and environmentally. We implemented or we realized energy strategies for various municipalities. We implemented pilot measures. We did an analysis of the economic viability and the effects of low temperature district heating, also developed business models. And we did capacity building via a training program, which has been developed in the project. At this point, I think I'm going to hand over to Adam.
With this introduction of our motives, we would like now to proceed to the content of our project and of our investigation. As a normal people, we first started to learn what has been done up to now, and I will focus in my presentation what we have learned about the existing solution for fourth generation low temperature district heating. And a very important issue, which was already mentioned by Georg, we couldn't switch by just clicking a system of old type, third generation to the fourth generation. We need kind of the roadmap how to reach this level of low temperature district heating. At the end of my presentation, I will shortly describe the solution which has been developed during our project, and will point to the timetable when the solution will be presented to you. Yes, if you look on this graph, you will see that energy, the temperature of your district heating can decrease with increase of energy efficiency of building. So if energy consumption in the building is decreasing, we can also decrease temperature of your nets. This was studied in Sweden by E.ON. And another slide from E.ON, which nicely describe a situation on the time scale, how from first generation of district heating we reach the fourth generation district heating with a temperature below 60 or 70 in the winter degree. And we change, of course, the fuel from coal to in third generation also the waste and biomass. Eventually, with renewable renewable sources integration, we can come to the solution of the fourth generation. In the future, this development will focus on demand side response, heat resource storage systems, surplus heat integration. And this was done, for example, in the famous E.ON solution Ectogrid, which I shortly mentioned. So what are the low temperature district heating grid? Firstly, the low temperature reduces heat losses, which is very important, increase of efficiency. Then we can, of course, enable much easier to include the renewable energy sources. We can also enable to include a low temperature waste heat or surplus heat, which will be presented later. Of course, another issue is to reduce thermal stresses of pipes, which help to prolong district heating life. And finally, low temperature of return flow enables better application of this low temperature flows to flue gas condensation. I will now try to show you what we have learned during this first process on this issue. It means new city districts, which is a solution for the new completely system. And I will just show you an example from Berlin-Adlershof and Ectogrid Lund. Then I will show another road related to the existing houses, one which are renovated after renovation, another is done in Denmark on non-renovated houses. Then I will show you another issue of lowering temperature in the whole district heating grid. This will be a Polish example in Łomża. And then I will speak shortly about some examples of surplus heat utilization. Yeah, very good example we have seen in Berlin when we have been visiting the Berlin-Adlershof and the investment done by BTB Berlin. We have seen the introduction of such a low temperature district heating into the greenfield investment, 62 energy efficient buildings with 15 watt per square meter the power need, and then including that there was some low energy and 3+ energy buildings, which means that some of the buildings have produced their own heat, which can be introduced by bidirectional the connection to the heat, and can be later in 2 years period of clearing be used in a later time when the need for the heat is larger than in summer. This is provided by BTB, this clearing, and this is a very generous 2-year period of clearing, which helps the small producer to use their own produced heat in this famous scheme of prosumials. This low temperature district heating was linked to existing district heating and to their return flow with a 60-degree supply temperature to the low temperature district heating and 40-degree in return. And it was estimated that 65% of primary energy was in this way saved. And lesson learned, which was very important for us, for a new investment in such a greenfield situation, very important is the competition with other solutions like heat pumps or gas boilers. Such an investment needs a very careful planning and also work to encourage citizens to take part in this solution. Very interesting solution is proposed by E.ON, which is related to the system of connection of heating and cooling. You see here 2 lines of a temperature of a district heating, one line with a cooling purposes and one for heating, and then both of those lines they are working at the temperature between 6 to 30 degrees, depending on the time of the year. Usually the difference between both of them are about 10 degrees, and the heat pumps are using the temperature which the hot line when they need to warm, and the cold one when they want to cool. So by such let's say balancing procedure, they can save almost 11 gigawatt-hour per year, and the whole system of these buildings, which are presented here on the photo, use only 3 gigawatt thermal in year. Yeah, another way to introduce on this roadmap, to introduce a low temperature district heating is to renovate the buildings. You can see here the buildings before renovation in Albertslund and after renovation. The renovation took into account isolation of roof and walls, and of course isolation of windows, toilet, and new radiators. And the whole idea of low temperature district heating is presented very nicely here. When we have a district heating grid supply houses with 57 degrees, after the heat exchanger the 52 degree is going to the radiators. From radiator is going to the floor heating system, and the temperature coming back is about 30 degree, quite nice temperature drop, which means that there's efficient energy and heating supply. It was found that 50% reduction was accomplished in bills paid by the customer, and so we have learned that this low temperature district heating is economically feasible for renovated houses. It means we can pay our debts by such a solution. Of course, the task to renovate the buildings is a huge task, and we couldn't probably do it in a few years. So the question which has been also formulated by our Danish colleague is, what about the not refurbished cities, what not refurbished houses, and especially in the case of such a district in Zonderby, they found that after exchanging of the old and not efficient piping, they can decrease heat losses from almost above 40% to 30%, and the temperatures which has been supplied were around 45-50 degree to the house, and the return temperature was above 20 degree. So we learned that the house solution is feasible even in for non-renovated houses with floor heating. Another interesting solution was shown to us by our colleague from Warsaw Technical University, Dr. Dzierzgowski, who was introducing such a very interesting experiment on the whole city network, which is a city in the eastern part of Poland. Verified heat demand, 73 megawatt thermal, 860 substation, the length of the district heating 160 kilometers, heat losses about 12%, and the goal was to lower the temperature into 2020 to 89 and return 48, and decrease heat production from coal from 100 to 11% in 2022. On the first step, which was very crucial, you know, generally in the east part of the Europe, the many houses are renovated, but the energy demand has not decreased enough because there was not done as a regulation in existing substation. After such a regulation, we can decrease a mass flow of 55%, it increased temperature drop to 43%, and decrease heat consumption in the building even 30%. This must be done in each building, and it was done in Łomża, and the effect was very interesting. The temperature was already decreased to 109, and from 12% to 10.6% heat losses were decreased, and average seasonal district heating temperature 45 degree. In the final stage, the new solution, new biomass-fired boilers and new gas-fired heat plant are introduced, and this can, of course, decrease coal consumption to 11%. Yeah, the final things which we have learned, it is also the surplus heat. And here you can see the example in Hamburg. Hamburg is the headquarters of the Arubis company, which produce copper. And during the copper production, you release SO2, which can be later converted to sulfur acid. During the final process is exothermic, so it releases the heat, and such a one line already support 80 megawatt thermal for the Hafen City East. Two other will be introduced in the future. Even this one line permit to reduce the CO2 emission by 4,500 tons. Another solution which we have studied in Poland, it is the local utilization of surplus heat in the company, which use a soldering furnace for the production of heaters. And you can see that such a one furnace about 630 kilowatt thermal, and gives after the surplus heat has a temperature 70 degrees. It can be used for space heating, ventilation, and domestic hot water preparation with different temperature range. And about 40% of the heat is used for the heating purposes. You can see that the 5 years is a simple period back time. We are just under investigation of this example, and we hope to get with a proper results soon. And of course, this can be heat supplies can be used locally, but it can be also considered to be transported to far distance. And such a discussion has been done in our partner country, Kalundborg City, and they have been questioning what can we do when we have a big amount of surplus heat, low temperature, about 20 degrees. How far we can feasibly, economically, in feasible way to transfer this heat to the other citizens. And it was found that even in such a line with 20-kilometer distance, it can be paid in 12 years, which is a very good result. Yeah, and on the basis of this knowledge which we have learned, we propose new pilot testing measures. You can see here the different pilot measures which has been checked. You will see after lunch a presentation on what has been done with an innovative piping system in Helmstedt University, in Helmstedt City, by Patrick Johansson and Rolf Strander at 1330. As it was mentioned already by Britta, we have been also working on the development of strategies, and you will see here the 3 different lectures by our colleague from Cottbus University at 1310 about the pilot energy strategies. Then our colleagues from Riga Technical University will speak about sustainable assessments, and the strategic information about financing schemes will be given by Cecilia Tapper from the Sustainable Business Hub in Sweden. And finally, what we have learned in our visit tours, we have taught in various meetings, various seminars, and finally it was developed a seminars package, training package in Zebał and it will be presented by Jan Gerbitz at 3 p.m. So now I'm just giving the word back to Britta. Please continue.
Thank you very much, Adam. In the last slides, we would like to present, after we had presented what motivated us for the project, what has been implemented, what did we learn, where do we go, what will be the future. First of all, some conclusions after 3 years of project implementation. Within our project, district heating grids have been confirmed as an essential infrastructure for cities and in the Baltic Sea region, being beneficial for various stakeholders, our so-called target group in the project, municipal authorities, planners, but also, of course, for the consumers. At the same time, district heating has been acknowledged as a sustainable and future-oriented heating supply. Of course, we knew about this, but all the project activities confirmed this to us. What also has been confirmed, that expert knowledge, research, and technical solutions are available. There has been done enormous research, and there are acknowledged universities in Denmark that have been published so much about smart 4th generation and now 5th generation district heating systems. So this is available. The knowledge is there. The knowledge is there with the experts. And with this knowledge, a widespread acceptance has been achieved that technically it can be done. Low temperature district heating is possible. So there's the potential to expand sustainable and smart district heating. But there is a but. What we have seen is that so far, low temperature district heating is very seldomly installed in Europe, and especially in the Eastern European countries. Adam just presented some remarkable installations, pilot projects we have seen, but we had to search them. Being frank, we had to search them. It's not that you just go, hey, we go to this country and visit 3 or 4 smart and sustainable district heating grids. That's not the situation. Low level of investments in low temperature district heating due to financial concerns. And as I've written here, investors need to acknowledge that it's a long-term investment. Yes, it's a long-term investment, but with very positive environmental aspects. We will speak about this in detail in the afternoon. Also, new approaches on how to use waste heat are needed. And there is a lack of knowledge and strategies how to implement these systems with municipal and regional stakeholders. So their knowledge needs to be increased. Knowledge with the experts is there. Knowledge on the regional and local level has to be increased. So our conclusion, there is a need for training and awareness raising activities in the Baltic Sea region. And this is, we have done this in the project. Jan Gerbitz will present the training program we have developed. But then another but there needs to be done more. And this is our outlook in the into the future. We, the LowTEMP project, we're going to continue capacity building. And we're going to do this with a so-called extension stage project. So we get the possibility for 1 year to continue our work with 10 LowTEMP partners. The LowTEMP 2.0, it's called, project, is based on the capacity building results of the main project and responds to this large demand of knowledge. What are we going to do in this project? We're going to adjust the LowTEMP training material to the national conditions of the participating 9 countries. In this context, we're also going to translate the training material. And we're going to develop e-learning courses. When I wrote the application, when we developed this project 1 year ago, there was no COVID. But also then we thought, okay, e-learning is good. We cannot only do on-the-spot seminars. In the meantime, I think these e-learning courses are very, very important because virtual and remote meetings will be the form of meeting at least for a few months, I guess. So, but at the same time, we also planned national training seminars and promotional events in the countries. So this is LowTEMP 2.0. Tomorrow we are going to have the kickoff of this project. My last slide, our last slide, we continue capacity building, it's saying, and we would like you to cooperate with us. First of all, please visit our website and have a look at our outcomes and project results. Of course, we have a Twitter account. It's LowTEMPDH. Please join our network. Get in contact with us. Let's exchange on low temperature district heating and smart district heating grids. We are there, and we would be very, very happy if you, after having a look at the website, join our network, write an email. Email address comes soon on the next slide. With regard to LowTEMP 2.0, I already would like to announce, get familiar with our training material. It will be also published on the LowTEMP website. Feedback is welcome all the time. You're also welcome to take part in the training material. So just contact the national project partners and please support us by promoting our training material and the e-learning courses after they have been developed. which will be in autumn next year. We'll finalize this. And the usual slide at the end. If you would like to get in contact with us, you're welcome to do so. So I guess I always stick to the time, and I'm saying thank you very much for having the possibility to speak about the LowTEMP project.